I'm back for part 4 of our Ender 3 series. Last time in part 3 we started tweaking slicer settings so we can try to get the best possible print off of our Ender 3. And there's a lot of different settings to go over, so that's exactly where we're going to pick up from today here in part 4. And if you haven't seen part 3 yet, this video might not make so much sense unless you've seen that one, so I will leave a link to part 3 up here in the corner. But let's not waste any time, we're going to jump right back into Prusa Slicer. So back into Prusa Slicer, it was pointed out to me last video I didn't explain the different modes of Prusa Slicer, and that's these up here on the right. You can do simple, advanced, or expert. I am in expert mode. This just limits you to the number of options that you can see in the different menus. They are color-coded in the menus as you go through, that's what that color means on the left. So we are looking at expert mode. With that out of the way, let's head to print settings. And let's talk just a little bit more about extrusion width. By the way, Stefan over at CNC Kitchen has a great video on just this subject. He explains it really well. I'll leave a link up in the corner. But basically, a lot of these settings are just going to be for fine tweaking of your print. Unless you change them a lot, you're probably not going to see a lot of results just by looking at them with the naked eye. You can try to calibrate these settings somewhat, and we will attempt that here in a moment. But unless you see something really specific that looks odd on your print, I wouldn't adjust these from default. One thing to consider though, if your extrusion width is too high, the Hotends is going to try to pump out enough filament to make that extrusion width just a little bit wider. And that might be taxing on your extruder. So if you're getting skip steps, something like that, maybe check your extrusion width, maybe it might be set just a little bit too high, and your extruder / Hotend can't keep up. But let's just see what our extrusion width is. So let's change the layers and perimeters of our print. We'll stick with our layer height of 2. That's the vertical setting. We're going to go down to 1 shell because we want to measure just 1 layer width. And we'll just do no tops, no bottoms. And we want the cube to be hollow, so let's go to infill and just temporarily, we'll set that to 0. So let's go back to the platter. Let's slice that. And we have our hollow 1 shell cubed. So let's print that out and then we'll take some measurements. And our single wall cube is done. Let's take a measure. So the best way to measure these is with your micrometer. You're never going to be able to get these completely accurate because of the accuracy of these 3D printers. It's just not going to happen. But you can get close. This side we have just a bit over 44, just a little over 45 on that side, a little under 45 on that side, and almost 46 on that side. And just a quick comment on micrometers, this is a very inexpensive one from Amazon, but make sure that your 0 mark lines up, make sure it's calibrated. You can use your wrench to calibrate the barrel if you need to, but turn it down to 0 and make sure that line lines up as good as you can. And never turn your micrometer from the barrel, always turn it from this ratcheting part so you don't get too much pressure on it and cause inaccuracies. So I'm pretty happy with this initial print before we made any changes. We could maybe get a little more accurate, but I don't think we need to. It's not going to matter that much in the long run. And if you're trying to calibrate that extrusion width, there's a couple of ways you can do it, but the 2 easiest ways are with the filament. You can either adjust your filament diameter. Measuring that filament over a couple of meters, I came out to an average of about 1.74. I don't think that's enough to make a difference, so I'm going to leave mine at 1.75 just to keep it easy. But if you reduce the diameter of the filament, that's going to cause the extruder to try to catch up. So it's going to extrude more filament. And if you increase the diameter, that's going to try to slow it down and it'll extrude less. So let's change this to 173. I did run a test print. I'll show you that in a moment. But let me show you these sliced files side by side. So if we take a look at those raw G-code files side by side, you have 175 on the left, 173 on the right. You can see by line 50, the 175 file on the left, the G1 command has extruded 4.102. And then on the right, the 173 file, the line 50 G1 command has extruded 4.151. So with that lower filament size, it's trying to extrude more to compensate for the loss of diameter in the filament. If we take a measure of our 173 cube, we have just a bit under 45 on that side, almost 46 on that side, almost 46 on that side, and about 46.5 on that side. So with that 1.73 diameter change, it's just a little bit thicker. So for these tests, I think my filament is accurate enough. I'm going to go ahead and leave mine at 1.75 in diameter. But to correct these kinds of things, you can also adjust the extrusion multiplier. That's the flow rate. The lower the number, the less the extrusion is going to be. The higher the number, the more it's going to be. So let's change this to 0.9 and take a look at those G-codes. We have our standard 175 with a 1 multiplier on the left and our 175 with a 0.9 multiplier on the right. You can see by the time it gets to line 50, 175 has extruded 4.102 and the 0.9 multiplier has extruded 3.928. So taking it down to 0.9, that's a pretty good reduction. And if you would like to figure out what your multiplier should be, I'll go ahead and throw the math up on the screen and try to explain it. You'll want the desired wall thickness, in our case 45, that's our default. You'll divide that by the measured thickness, so let's just say it was 46, and then you'll multiply that by your current extrusion multiplier, we'll just say it's 1, and that will give you the new extrusion multiplier, and I suggest you just round that number up, and then whatever that number is, you can enter it right here. Again, these are very fine settings. It's probably not going to matter too much in the long run, and if your filament's accurate, you shouldn't have to mess with these at all. And if you want to take a look at those two prints super up close, here they are side by side. This side is the 175 print. This side is the 173 print. And you can see just a little bit of difference, I would say, but this is the kind of level that we're getting to here. It's microscopic. And it's not that it doesn't matter. You can see these effects in the prints, but this is how fine a detail we're getting here. And heading back into Slicer, if we take a look at our Advanced tab, I'm still not going to change any of the extrusion widths. I'm going to leave them at default. I'm still achieving that perimeters value of 0.45, so I'm happy with that. And print settings, we're not going to save these because the only thing we changed was to get it to print that one layer cube. So we're going to revert back to our original settings with our 10% infill and our 3 perimeters, 3 tops, 3 bottoms. And from here, let's head back over to the filament settings and talk about cooling. So on the Ender 3, you don't have a whole lot of part cooling. The fan is not very strong, and the stock duct isn't all that great. Now, if you go super slow when you're printing and you print at the right temperature, you might not need a whole lot of part fan, but if you ever want to print very fast, you're going to need some. So we want to maximize the cooling as much as possible for this tutorial. So I suggest you keep fan always on. No matter what the fan speed might be, the fan will always be on with that setting ticked. And enable auto cooling. Auto cooling will slow down the speed of the print if there hasn't been enough time to cool that layer down before it lays down the next one. And in fan settings, I'm going to make the minimum speed 100. For PLA, I want it full blast all the time. So minimum will be 100, max will be 100. Bridge fan speeds 100, you want the most fan while bridging. Disable the fan, I'm going to leave that one layer. I want the fan on for every layer except the first one. The only reason why I don't want it on the first one is because I don't want to cool off the bed too much, and I want to give the first layer the best chance to stick down. And here's your cooling thresholds for auto cooling. Enable fan if layer print time is below a certain amount of seconds. By default it's 60, I'm going to make mine 100. This is trying to say if you have a really large print and that layer time takes over a certain amount of seconds, it won't enable the fan because it thinks that it has enough time to cool off that layer before it gets to the next one. We pretty much want as much cooling as we can get, so I'm just going to set it to 100 seconds. Slow down if layer print time is below a certain amount of seconds. Again, I want to maximize cooling, so I'm going to set this one to 25. So I'm going to slow the print down if that layer takes less than 25 seconds to complete. I don't want it doing the next layer until I have enough time to cool it. And then the minimum print speed, I'm going to set that one to 15. I don't like to set the minimum print speed too low because that can introduce dwell, and that'll cause blobs as well as other problems. So with all these settings, it's going to figure out what it can do as far as speed and slowing the print down to get as much cooling as I think it needs. So that's where I'm going to leave the cooling settings. Depending on the part, we only did the cubes before. This really isn't going to make a lot of difference on anything we've done prior, but it might going forward. So we'll make these changes. We'll go ahead and save them. And from here, I'd like to run another test print, but I want to go with a different object. At this point, there's one I really like to use. It's a pyramid of cubes, but it has a few different features on it that will show you some imperfections in your print. Here's our test object out on Thingiverse. I'll leave a link to this in the description, but let's grab that, throw it in the slicer, and then we'll run a test print and I'll show you a couple of things. So here's our first one. There's a couple of things that concern me about it right off the bat. On some of these upper tiers up here, the top finish looks pretty good, but you can see a few gaps down in here. So we might want to adjust that. That's going to be a few different adjustments, but we'll get to all those. The second thing is this top tier. If you turn it around, you can see that it's kind of pointed here on the back. That tells me we don't have quite enough cooling for a small section like this. It's actually kind of ovaled. It should be a lot more square than that. And then while looking on this side, this right here. Now that can be a couple of different things, but there is a bridge right there. And I've seen this condition on quite a few different models, and it can be just a little bit tricky to troubleshoot, but let's jump back into Prusa Slicer and I'll show you what we're going to change. So first up, let's tackle that top finish real quick. This probably isn't going to fix the issue altogether, but it will help. So we'll go into Print Settings, Layers and Perimeters, and let's just add another top solid layer for good measure. This will help with a few other things down the road, but we're going to change that one from 3 to 4. So now let's tackle that top cube. That section is all about how quick you can cool the filament while you're laying it down. So let's go back to Filament Settings. I know we've checked cooling before, but let's take another look at it. I said before that I didn't want to make this minimum print speed too low because we might introduce dwell, but we're going to have to lower it just a little bit more to be able to make that small section look any better. So let's take it from 15 to 10. We'll give that a shot. Now finally that fat section around that bridge. Let's go back to the platter and let me show you a few things. So we've made a couple of changes. We're going to go ahead and slice again. That shouldn't affect how our model looks really. But if you're setting on feature type, this is all fine and good. It's going to show you your overhangs over here in the key, all that good stuff. You can cycle down through. It's important to note the different types of infill. That can come in handy when you're troubleshooting. This is bridging infill, meaning that it's filling over the gaps of empty infill. And then you have solid infill. And then when you get to the top, the stuff you can see, that's top solid infill. And that's really handy to look at. But there's even better features in Prusa Slicer to use for these types of things. So if you come down here where it says feature type, and let's just switch to height. Now you would think that you set your height to 0.2 for all of your layers, that all the layers would be that height. Well, that's not the case. The slicer is going to make decisions on what the height needs to be based on what it thinks that feature needs the flow rate to be set at. So let's spin around a bit and take a look at our bridge over here. If we go down to that layer, you can see that it increased that bridging height to almost 0.4 millimeter. The printer's trying to raise the height of that to increase the flow rate to be able to bridge that gap. This can be handy sometimes depending on what you're printing, but a lot of times the printer can't compensate for that quickly enough and you end up with some inconsistency. So it's going to try to ramp up that height to bridge that gap, but then maybe it can't get it back down while it's continuing to print that line. And if you take a look at that underneath the microscope, you can see just how fat those bridging layers actually are. It's really trying to pump out the plastic to be able to get over that bridge, because that's going to support the next layer. So it makes sense somewhat. But that leads to what I was showing you outside the model view. See this fatter layer that you can see on the outside? It's ramping up to try to get over that bridge. And that leaves that inconsistency. So back into Slicer, we can combat that a couple of ways. But let's just make a few quick settings to see if we can get it just a little bit better. Back into print settings. One thing that has caused me issues in the past is this detect bridging parameters. It does try to do a good job and ramp up to try to get over that bridge, but sometimes it's a little flaky. So I like to just turn that off. So we'll uncheck that. And while we're at it, let's go over to advanced. And here under bridge flow ratio, I'm going to lower that down to 0.95. This will also help to try to combat that issue. And if we come back to the platter, slice again, and we take a look at height, you can see that it's taken that compensation off of those outer parameters. So that should get rid of that inconsistency on the outside. But we've just made a few changes, so let's go ahead and run another test and see what it looks like. And here's our next attempt. You can see just by changing up the cooling a bit, we are a lot straighter here. We don't have as pointed a corner. It's kind of square, still a little bit round, but we don't have a lot of cooling on this printer. Also, our fatter line down here over the bridge has disappeared. You can still see some inconsistency on those top layers, but it's not on that bridging layer. It's actually on the layer setting on top of those solid infills. Adding that top layer has helped us a bit on the top finishes. They look a little better. And just to show you again that bridge, that fatter line has disappeared. You can see the transition when it stacks on top of that solid infill. So we've cleaned it up just a little bit, but why are we seeing those inconsistencies on that top infill? Well, another feature that you can look at in Prusa Slicer, we can head down here and we can switch to speed. You can see these layers down here and these layers up here. Those are solid layers. They take a little bit longer to print, so it's going to be moving just a little bit faster. These layers in the middle just have infill in them, so they don't take as long to complete. So the slicer with auto cooling included are going to slow those down. This is what's causing those inconsistencies that you can see. As it speeds up and slows down, it's going to try to adjust that flow rate, and that's what can cause that inconsistency. All this stuff we're going to check out, and it'll make more sense as we go along. So overall, I'm pretty happy with the current quality we're seeing on the prints. We could just keep tuning the slicer over and over until we get them perfect, but right now I think we're at a good mix of quality, speed, and strength. But there is one more setting we need to tune that can affect the quality of the print, and that's retraction. Retraction is the length and speed of filament that the extruder pulls back while it's moving around to different sections of the print or different objects to keep it from stringing or blobbing. And it's pretty easy to calibrate in Prusa Slicer. We just need to run a few test prints while increasing that retraction setting to see when the stringing or blobbing stops. So that's what we're going to do now. So this is pretty much the standard STL file a lot of us use to test retraction. It's because that it's going to lift and move to each post, and if the retraction isn't set right, you're going to see stringing in between the two. Now with the Ender 3, it's Bowden, so you're going to have a little bit higher retraction setting because of the lag of the filament in that tube. Direct drive would be a lot lower. Usually Ender 3s out of the box, I would say start with a length of about 5, because the default speed is going to be 25, but let me show you the settings that we're going to use. We'll head to printer settings. I'm going to start with the default length of 2 and the speed of 40. And we'll get to speed in just a second, but I'm going to do the print at 2, then I'm going to move it to 3, do another print, move it to 4, on to see where the stringing stops. But speed is also important. If you take a look at the Ender 3 settings, by default, the feed rate of the extruder is set to 25. So you're never going to be able to move faster than 25 for a retraction speed unless you reset that. And you can do that with G-code, but I'm going to leave ours at 40 because that's the Prusa Slicer default. But if you selected Marlin for your firmware when you set up Prusa Slicer, if you go to General, you can see the G-code flavor right here is Marlin. Prusa Slicer is going to give you a tab called Machine Limits, and that's up here. Now Machine Limits, every time you start a print, it's going to inject G-code to set these limits for you, no matter what your firmware says. So basically, it's going to override those firmware settings. And these settings can be pretty high by default, so you might want to check these out if you're seeing issues down the road. We will probably get into these more in future videos, but what I wanted to show you is that every print, these settings are going to set your max feed rate for extruder to 120. So that is going to enable us to use that 40 speed on our retraction over there in our extruder tab. This setting right here. So every time we run a print, it's going to reset that default 25 to 120, so 40 will be valid. Now something that I would like to see come to Prusa Slicer, maybe it'll be in a later version that would make this a lot easier, is some sort of multi-processing. There are other slicers out there that have this ability. Basically, you can change the settings of the whole print multiple times in the same print. It would be really handy for the retraction test. You could change the length on the fly as you go up a certain amount of layers. And if you go to custom G-code, you can enter commands here before and after layer changes, so we can try to do something like that. But you can only use those to control stuff that can be controlled with G-code. So retraction length, unless you use firmware-based retraction, it can't be controlled like this. If you had multiprocessing, you could change those parameters layer by layer. If we head back to the platter, you can change some things layer by layer if you right-click, and you can do height range modifier. That will put the modifier over here, and then you can right-click on this gear and change some things. But mostly it's just things like infill, some of the layer parameters, support. It doesn't have all of the slicer settings. Having the ability to change things layer by layer for all the parameters inside the slicer would be super powerful. Hopefully we'll see that someday. Now on to the test prints. So here's our results. Here's the 2mm retraction length. Not surprising that it's going to be really stringy. And this is 2.5 millimeters of length, which is kind of surprising because there's only one little string there at the bottom. It's actually already starting to look pretty good. And that's 3 millimeters of retraction length. We've pretty much resolved all the stringing issues altogether. Just for fun, I did continue running up the scale. This is 3.5, and I took it all the way to 6 millimeters. This is what 6 millimeters looks like. I just wanted to show you this because you can start to see it actually taking away from the print, especially if you take a look at the top of this model. You can see the retraction so high it's actually left holes in between the layers. So you definitely don't want to set retraction any higher than you have to. So back to Prusa Slicer, down here in retraction length, we're going to set ours to 4. So why are we going to set it to 4 when we saw that 3 was probably good enough? Well, in the past, I've seen that retraction model. It is a pretty good test to set your retraction. It's a really quick print. But there's a lot of situations where that retraction probably won't be high enough. So I like to go just a little bit over what I see on that model. A length of 4 on an Ender 3 with this long of Bowden tube isn't anything out of the scope. This should be just fine. So after the retraction calibration, we were able to set the retraction down a little lower than I normally would on an Ender 3, but that's because we have the filament tuned in so well with that extrusion multiplier, and we're running on the cooler side of temperature for this filament. You can control stringing and blobbing a little bit with the temperature. If you're seeing it on a certain type of filament, lower it down a little bit. That should get rid of some of it, but as always, every filament is going to be just a little bit different. So now that we have things dialed in a bit, let's go ahead and run a benchy. Just kind of a side tip here, you might have noticed while we were printing that benchy, that our benchy was actually printing somewhere in this neighborhood, not in the middle of the bed. And that's a setting that can be corrected in the slicer or in your firmware. Since this is a stock Ender 3, we can't edit the firmware quite yet, we don't have a copy of it, so we can correct that in Slicer. We want it to print in the center of the bed as much as possible. So let's go over that real quick. So if you put the printer to home in X and Y, you'll notice that the nozzle is actually a little bit to the left and in front of the bed. Well, we need to compensate for that in the Slicer, because the very corner of the bed is 0, 0. So if you tell it to move to 110, 110, it's still got to compensate for the travel to get to the bed. So that's why it's going to be uneven here in the center. So I'm just going to home all, and I'm going to measure how far it is from the nozzle tip to the corner of the bed. So we're at about 5 millimeters in the Y, and roughly 2 or so millimeters in the X. So if you go back into the Slicer, you can compensate for that. It's in your printer settings, General. We'll go to Bed Shape again, hit Set. We're set to 220, 220. And we're going to want to change our origins to compensate for that. But it's important to note, this bed size is set to 220, 220. That's just a safety measure. The size of the bed on the Ender 3 is actually somewhere around 235, 235. If you set it to 220, 220, that'll keep you away from clips or the edge of the bed, just get you in an area where it's safe to print. This is just the setting inside the Slicer that it uses to give you that warning, hey, this model's too big to print on this printer. So you have to take that into account when we're going to set this origin offset. So when we measured, we got a -2 and a -6. And that's where we measured for the corner of the bed, but remember we were measuring for a bed that's actually 235, 235. So we'll take our 235 value and we'll subtract our current bed size, 220, and we only want half of that because we're just coming from one direction. So these values would actually need an additional 7.5 millimeter to get you around the center of the bed. So to make up for that, let's do X 9.5 and Y 13.5. That should get us a lot closer to where we need to be. So we'll hit OK, and we can try that again. And now you can see we're much closer to printing in the center of the bed altogether. Just a little side tip that might help you out. And here's how our benchy came out. It's not the best benchy I've ever seen, but most of the issues we're seeing here are probably related to machine limits like acceleration, speed, or jerk. And we haven't even touched any of those topics yet. If you take a look at artifacts like this, we call that candy striping. And that is more than likely related to the drivers that are being used on the board, the stepper drivers. You can see the inconsistent layers. We have one down here, we have a couple up in here. You usually see those when you're transitioning from different parts of the model. Like right here, this is where the floor of the deck starts. These were probably introduced because of this porthole here. But again, on things like this, more than likely, it's because the machine can't handle that much speed. Now, I just happened to notice while the benches were printing, there are some other settings that I'd like to go over real quick, just to ensure we're getting the best print possible. And you can see inside this benchy how messy that infill is. And it is infill, it's not going to matter that much, but I have had the occasion where sometimes the retraction didn't go quite right, and some of this extra material got caught on the nozzle, and it caused the print to fail. It's going to add a little time to the print, but it will further ensure that the print succeeds. So I think they're worth turning on. So let's take a look real quick. So there's a couple that I like to change. Let's go to print settings, and we're going to go to infill, and I'm going to untick only retract when crossing perimeters. And this is the setting that's going to keep it from stringing across the infill. Again, it's going to add a little bit of time, but I think it's worth it. Go ahead and untick that, and let's head to printer settings. And under extruder, we have minimum travel after retraction, retract on layer change, and wipe while retracting. If you have an object that has a lot of points that are close to one another, you're not going to get a retract in between those 2 points unless they're over this 2mm distance right here. I like to lower this down to 1. If you can do that move in 1mm, you probably won't even have time to ooze, so you probably don't need the retract, but I think 1 looks better than 2. So let's set that to 1. And then we have retract on layer change. I'm going to go ahead and tick that to on. And that's exactly what it says it is. When you do a Z move, when you go up to the next layer, it's going to perform a retract. This will keep a lot of blobbing from happening. And you're not going to see that right now in our prints because we're moving at a relatively fast speed, but you might see it later. And then finally, wipe while retracting. This one's a little harder to explain, but not that big of a deal. It's going to do an additional move while it's retracting, just in case there's a little bit of filament that's still in the nozzle before it pulls it back in. So if we head back to the platter, let's do a slice, and let's tick on our travel moves and our retractions. So let's take a look at just one layer so it's not so busy. So this is what the travel moves look like before the wipe. Let's zoom in a bit and we'll focus on the flag holder. It's probably actually easier if we turn retractions off. So it does the retract right here, but then this red line is the wipe. It's going to move around one of the layer lines, trying to get rid of any plastic if there's any left after that retract. Again, I'll turn wipe off just so you can see the difference. Wipe off, wipe on. Again, it's going to add a little bit of print time, but it might make your print look a little bit nicer, especially if you're seeing things on the outside of the print that might look like leftover filament. You might want to turn wipe on and see if that makes it go away. And the results with all of those turned on, you can see it's much cleaner inside the model. This one outside over here, that's from when I stopped the print midway. Don't worry about that. But it's much cleaner and it's just a little added security to make sure your print finishes. Now we're not going to get crazy into speed settings today because there's a whole lot of information to go with that. There's a lot of settings that need to be tweaked equally to get it to print successfully. But there is something you can do as kind of a pinch fix if you want your print to come out looking as good as possible with minimal amounts of tweaking. You can just lower the print speed. So let's take a look real quick. Let's click back over to speed, and you can see these speed changes. It's slowing the speed down in here because these are thin walls. It doesn't have a whole lot of room to lay down the filament, and there's some gap fill inside there. And if we go back to look at our benchy, kind of looks familiar, huh? These areas, that's where it's trying to do the different speed changes to make sure that it gets that thin wall done correctly. But what if we come in here and we just go to print settings, and we go to speed? Notice we're doing perimeters at 60 millimeters a second, and then 50% of that on the external perimeters. Also, we have a first layer of 30. What if we just slow down quite a bit to alleviate that print speed change? Small perimeters are okay. 15, it goes extra slow on those because it's trying to ensure that gap fill is done correctly, as well as the outsides. But let's keep it from varying so much. Let's set perimeters to 20, and we'll set external perimeters to 20. And just to match, let's do first layer speed 20. Now our previous benchy took around an hour and 50 minutes. Let's head back to the platter. Let's slice again. This one's going to take about 2 hours and 12 minutes, which is a pretty long benchy. But let's take a look at that speed feature type again. We still have this band where it's going to slow down some, but it's much more comparable to the rest of the parts. So the effect of that slowdown isn't going to be as drastic, so you won't see that inconsistency of the layer. The extruder doesn't have to try to compensate for that, so you won't see those lines. So we would go from this benchy that took around 1 hour and 50 minutes to this benchy that took 2 hours and 10 minutes. But you can see how much nicer that outer perimeter is. It's not perfect, but just by slowing down, you can get a lot nicer print, but you gotta wait. So the benchies are done. There's probably a few settings that we could tweak to make that benchy look even better, but right now for the initial slicer config, I think they look pretty good. But before we end this video, how about we do a print just for fun, one that's a little bit more intricate, just to see how it turns out. And the model that we're going to use is this orc that Vedran created. You might know him as Wexter over on My Mini Factory. He creates some really awesome stuff. This thing is super detailed, and it should be a pretty good challenge for the Ender 3. This model is available for just a few bucks. I'll leave a link in the description. I highly urge you to go out and check out all of Vedran's stuff. There's some really cool models. I am going to go ahead and scale this down 50% just so it doesn't take so long. That should be much easier to manage. So let's go ahead and print it and see how it looks. And here's our orc. This one took 5 hours and 30 minutes. This is at that 20 millimeters a second perimeters and external perimeters. And he doesn't look perfect. He's going to need a lot of work. It is a very detailed model. The camera kind of adds a weird effect here. There are a few layer inconsistency issues, a little bit of stringing, a few blobs, but not a terrible print, especially for a printer that costs around $150. And just for reference, this one was done with the faster setting, the 60 millimeters a second perimeters with the 50% on the outside perimeter. This one took 4 hours and 30 minutes, but you can see there's quite a few inconsistencies, especially up here on the horns when it gets to the smaller details. It doesn't look bad, but it doesn't look great either. And here are the two side by side. This one is the 60 millimeters a second. This one is the 20 millimeters a second. There are a lot more things that we can adjust to solve a lot of these problems, but just these quick fixes that we've made, we're starting to get a pretty decent profile going here. Most notable at the slower speed is how clean a lot of the corners are. You can see right here at the faster one, and then over here on the slower one, the edges are a lot cleaner. The details on his arm plate here as well, these little notches, they're a lot cleaner on the slower model. So we have work to do, but we're getting there. And that's it for this one. We did tweak a lot of slicer settings. We are starting to get some fairly good looking prints, but we're printing pretty slowly, and we can do better than that. But we're going to have to get into some of the machine limit settings like feed rate, acceleration, or jerk, or even junction deviation if that's the route we want to go. But that's a whole lot more information, and that's going to be for future videos. You are welcome to try my current slicing profile. I'll leave a link in the description. Hopefully you found this helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.